Alright, for lesson 1 of this first unit, we're going to talk about slope-intercept form, and that should be review. And we're also going to talk about function notation, which I believe is something new. So as a reminder, slope-intercept form, y equals mx plus b, you can see here in the middle of the screen. The m letter, which is a variable, of course, which stands for a number, is the slope of a line. And b is the y-intercept of a line. So the slope-intercept form specifically says that y is by itself over here on the left, and you have something times x plus a constant number. Now some questions for you to consider, and we're not going to answer these in the video, but we are going to talk about them a bit in class. Why is the equation written this way? The order of this equation. Why does m have to be with the x as the multiplier, and why does b have to be by itself? Why couldn't slope-intercept form be the y-intercept times x plus the slope? Why does it work this way and not some other way? Now there are three representations of a function that we're going to look at most often. These aren't the only three possible, but these are definitely the three most common, at least for a math class. So the first one is the equation of the line, or the function. Y equals 3x minus 4 is an example. And then we have the graph of that function, which is this purple line you see here in the graph. And we also have a table of values that we could use to represent the function. Now this is definitely not a complete table of values because the equation or the function itself would have an infinite number of points that make up that function. So we could go forever backwards, negative 4, negative 5, negative 6, going up the x column, or we could go forever down 4, 5, 6, plus we have all the decimals and fractions in between, any number you can think of. So these are three ways to represent a function. Which of those three do you think is the best? That's another question that we're going to address in class and not answer so much here in the video. Okay, function notation. What is function notation? That's the first question. Well, function notation is a way of representing a function that gives us a little bit more versatility as compared to just using a y. So you can see here in this example that we're going from y equals mx plus b to using this f and then x in parentheses equals mx plus b. And the way you say that is you pronounce it as f of x. Okay, so this would be said f of x equals mx plus b. And you can use any letter you want. It could be g of x, h of x, t of x, whatever the occasion calls for. Or you can just arbitrarily pick a letter. Now why do we use this notation? Well, there are several advantages. One of them is that it lets us refer to a function by its name. For example, function g. So if you see a graph that has two or more functions on it, rather than having to say the equation of that function or to point out the color of it or say it's the one that goes this way, you can say function g in reference to a discussion about a function. It also allows you to more efficiently find the value of a function at a certain input, and we're going to look at an example of that in just a minute. It allows us to combine functions in certain ways to more easily work with complex functions and combinations of two or more. And later in this unit, we'll look at a couple examples of that. Now, there are some more advantages as well, and we'll get to those as we go throughout the year. Can you think of any disadvantages? That'd be something good to bring up in discussion. So let's talk about finding the value of a function then. Now, I have this function f of x equals negative 2x plus 5. So I want to find out what is the value of f when the input or the x value is negative 2. So f of negative 2 equals negative 2, because it's negative 2x plus 5, and in place of x I'm going to put negative 2 and then plus 5, and so I have, that's 4 plus 5, so I get 9. F of negative 1 is negative 2, and I put a negative 1 in place of x, plus 5, and that equals 2 plus 5, which is 7. F of 0 would be negative 2 times 0 plus 5, and so that should give me 5. F of 1, you should start to see a pattern here now. It's going to equal 3, and then f of 2 is going to equal 1. Okay, now notice in this column of values here, the x's are going up by 1, the inputs I'm using, negative 2, negative 1, 0, 1, 2, and you can see that the common difference here each time, it's going down by 2 each time I go up by 1 input. Okay, and we talked about that. All right, so let's rewrite this linear function and put it in slope-intercept form, and then I'll change it to function notation, and then we'll graph it. So to get slope-intercept form, the first thing I want to do is get y by itself. So I'm going to take this negative, or this 6x term, and I'm going to subtract it from both sides. So I have negative 2y equals, and I want to write the x term first, and then the constant term, because remember, slope-intercept form says it's something times x plus or minus the number. And then I want to divide both sides by negative 2 so that I can get y by itself over here. Notice those divide out, and so I get y equals negative 6 divided by 2 is negative 3. Sorry, that's negative 2. So that's positive 3x. 12 divided by negative 2 is negative 6. Now to put it in function notation, I'm just going to change the y to, say, g of x. So now I can say function g equals 3x minus 6. Now to graph this, I want to start with the y-intercept, which is negative 6. I'm going to have a point right here. And then I want to use the slope. Now remember, slope is rise over run. That's one of the things that you might have remembered from last year. We also could say it's a rate of change. We talked about that as well. So the rise over run, in this case, is the rise of 3 and a run of 1. So I'm going to go up 3, so 5, 4, 3, and over 1. So there's another point on my line. And then 2, 1, 0, over 1, and so on. I can do that as many times as I need to until I get a picture of the line. So the line looks something like that. So there's the graph. Here's function notation. The original was in a different form, so we changed it to slope-intercept form and then graphed it. Let's do one more of those. So the first thing I want to do in this case is simplify this stuff on the right. So I get negative 2x if I distribute minus 8, distributing the negative 2 here. And then I'm going to add 3 to both sides. So I get y equals negative 2x minus 5. So there's slope-intercept form. Let's change it to function notation. We'll say h of x equals negative 2x minus 5. So I have a y-intercept here of negative 5. Slope of negative 2, so remember that's negative 2 over 1. So I'm going to go down 2 and over 1. So the line looks something like this. Okay, remember, positive slope goes upward from left to right. Negative slope, like this one, goes down.